All right, everyone. Thank you for coming. And there's one thing I would like to talk about to begin with. So since yesterday, there was a new question on the Google Doc, just one. So I'd like to talk about it first, and then after that, you can ask me any lecture-related questions from week 1, week 2, week 3, week 4. They're all welcome. Okay, the first question here. That's to do with the abstraction function. So remember, for this week, you have to understand what an abstraction function is. Okay, if you don't understand very well, bring it up, and then I can explain it, clarify with you. Okay, let's read the question together. Shouldn't the model feature be marked as none? So as we learned from the lecture, whenever you put a feature section there, and if you simply say none, so it's almost like a putting private modifier in Java. So that means every feature under that particular section will be hidden, completely hidden, so private. Okay. So now the student's question was, why don't we put none besides the model? Okay. And then because in that case, the client shouldn't see how it is implemented. Okay. There are two confusions over here, which I'm going to clarify. Okay. Because your fellow students seem to believe you can only hide the implementation by marking the method or routine to be private. That's not the case, right? Implementation is hidden anyway. Okay, I'll show it to you. Okay, it appears that the client should never have to directly call the model, and it is used in post conditions. I would say this one is not so accurate. So basically, for clients, when they see your contract view, basic contract view, you can think about you only show the public items in your class. When the clients see the public or contract view, they definitely will see model. And then the model will be a very good indication about how you actually make you how the commands or routines are supposed to work. Okay, let me demonstrate to you right away. Okay, there are a few confusions here I would like to clarify. There's only just a few, excuse me, some very short experiment you can do by yourself. I'll show you how you can do it. For week number 3, let me show you how you can get it. If you go to the lectures page, and then if you go under week number 3 over here, and then you can see there is a source code for this week. So it's about how you can use the math models, specifically how you can use a sequence class to actually specify your stack, right? I did see something in the chat. I'll get to you in just a moment, okay? So that's the source code. If you download it and run it, compile that in Visual Studio, okay? Let me show you what you should really look at. So that's a project over here, okay? You can see under the feature sections over here on the right-hand side, right? You can see at the moment, we have abstraction function. And that one there is simply, you don't see any export status, like a none or to any other class. So that means it's completely public, okay? And then you can see at the moment, in the implementation over here, this is about how you can promote your implementation to the level of mathematical sequence, right? So the implementation potentially can be an array, or can be a linked list, or can be any data structure. So that's the part we would like to hide from the clients. That's number 1. And number 2, you can see from the post condition over here, we are trying to specify how you relate the output sequence. You can see the return type over here is simply a sequence. What's the relationship between the output sequence and the implementation you're talking about? I remember Nora asked me a question yesterday. So would it still be satisfying the information hiding principle when the clients can actually see this in the contract view? Okay, let me emphasize again. Since yesterday I didn't open up Visual Studio to show you. Currently, we are in the editor view over here, basic editor view. I would like you to try to choose the contract view over here, right? You can see the last second icon over here. If you click on the contract view, okay, so that means everything that the clients wouldn't see will be hidden, including, let's say just a model, for example, right? So now you can see that even though the feature over here is actually public, so that means we can still, that means we can only see the public part of the feature. So now do we see the do end implementation? Do we see the do block? No, we don't. So in order to hide the implementation, you don't really have to make the feature private. Okay, that's one misunderstanding your fellow student was having. So hopefully they clarify that. You don't need to make the feature private just to hide its implementation. Implementation is always hidden, always. Okay. And now back to Nora's question yesterday. I just want to emphasize again. So you can see this model here is the only feature, the only routine where its post condition may refer to the underlying implementation. That's the only place. So does it really completely satisfy the information hiding principle? No, it does not completely. However, compare with the other case where we try to use the imp everywhere in all the push, pop, and also top, all the public queries. When we use imp in their contracts, compared with that particular case, we're not doing much better. So now if you see, for example, in the case of pop over here, right, you can see the way we define the public interface, like ADT, right, abstract data type, the way we define that is we only refer to the model, the public model query over here, but we don't really try to use imp anymore. So the only place, the single place we use imp is in the post condition. That's the only place. Okay. One more thing to illustrate what your fellow student was suggesting from the Google Doc. Your colleague was suggesting that maybe I should try to do the following. Okay, let me go back to the model over here at the top, over here. Let's say what would be the consequence if I simply export this to none, which means I'm making that private, right? Let's do that. Okay, so now before I do that, before I hit the compile, right? Let's just take one routine for example. You can see over here, let's say for top, for example, right? Let's look at the top routine over here. You can see for the top, we're simply having the precondition over here. Oh, by the way, you can use the model not only just in the post condition, but also you can use it in the precondition or in the variants. You can use the model in any context of the public contracts. They're all allowed, okay? Not just for post condition. But I would say typically you can write a more sophisticated contract in the post condition, which you will do for lab number 2. Okay. So now let's now say this. So now as soon as I hit compile, okay, you're gonna see we're gonna write into some trouble over here, right? Let's see this. If I say compile over here, right, we got compilation error. So this suggests number one, you just cannot just make the model query, which is kind of referred to in the precondition private. You cannot do that because they will simply say some clients have access to routine, but not to a feature used in precondition. Okay, let me just double click on the error. It's saying that in here, think about the precondition. Remember, let's recall from week number 1, what is really a precondition? Precondition should be considered as the obligation for clients, which means any potential clients, they should know in public what their obligation should be, right? In this case, if in the precondition, like a contract, if you refer to anything that's not public, it wouldn't be visible to the clients, right? So that's why this wouldn't compile. So any query or any any query or any attributes that's referred to in the precondition, that one is very specific just for the clients to inform them about their obligation. Everything must be public. But at the moment, model over here is actually private. So that's why it wouldn't compile. So what your fellow student suggested was actually in general not acceptable because it will actually make your code not even to compile. Okay. On the other hand, you might be wondering, so why can we actually refer to private attributes in the post condition, right? But my answer will be very logical over here, just basically similar to how I answered about the precondition. We said that precondition is actually for the obligation for the client. So everything there should be public. On the other hand, think about the post condition of specifying the obligation for the supplier. And if you really want to specify the constraint on the supplier, of course, you have to somehow relate to what's really happening under the hood. So what's really under for the underlying implementation. That's why for the post condition, you are actually allowed to refer to something that's private. But we know that having that practice there is going to violate, this information hiding principle and also the single choice principle, as we said, as the first part of your lecture series number 3, right? All right. Anyway, that's a very quick illustration to you. So just be careful. Okay. Okay. Let me change it back. So model should always be public, and then the only place you should really talk about. Let me go back to contribute, and then I will draw a conclusion on this. Model should be public, and also for any query, the only place. Okay, let me just go to model. The only place where you may mention about the. Let me just go back to model here. Sorry. It's model here. Okay, maybe I should recompile. Sorry. Did I do something? Let me go back to model here. Sorry. model here. Okay, sorry, let me change it back, right? Every time you do any change, please make sure you recompile. Okay, let me save, compile. Okay, let me now go back to the contract view. So if I go back to model over here, okay, so the post condition is the single place, the only place that you can mention about the implementation attributes, the private feature. That's the best practice we can have. You cannot really 100% satisfy information hiding principle, but I think we're getting as close as possible. All right, so that's about the answering the first question here. Okay, let me close this. Okay. Let me see if there's any new question added to the Google Doc, maybe while I was talking. There doesn't seem to be anything. Okay, so we're done with Google Doc. Let me close it, okay? Okay, I see one question here from Gleb. Is there a protected modifier besides public and private in iPhone? It's no. There's no protected. I know in Java, protected means it can, it's actually something accessible by your subclasses, right? I would say this, let me mention something quickly to you, and then not in week number 4, but in week number 5, we will talk about export status. We'll talk about it systematically. So let me just give you a little bit preview, okay? But I think as far as now is concerned, you just have to know how to make something public and also how to make something private, okay? Let me just give you a very simple example here, okay? Let's say over here we have class, okay, just make sure I'm showing my iPad. So here we got class A, okay? And then let's say over here, feature. And then let's say export it to, let me say B here, okay? You can put as many classes as you like. If you want to put multiple classes in the export status, just separate it by comma, okay? Let's say I will simply say feature number 1, okay? And then the rest. It can be a command, it can be a query, okay? I'll just omit the details here. Let's have another one over here. Let's say feature over here. Let's say B and C, okay? Just making example here. And then F2, all right? So let's say that's our supplier class over here. So let me put it into one block over here. And then let's now try to do some experiments, okay? So what this is saying is F1 is only available to in the context of class B, whereas for F2, it's only available for in the context of B and C, okay? Let's try something here, right? Let's say I'm now in the context of class let's say class D over here, right? Let's say somewhere like that, okay, somewhere, okay? Let's say I declare a local variable of type A. Let's say objects of type A, okay? And then that's declaration. And now if I simply say objects dot F1, and then somewhere I say objects dot F2, okay? So that's client number 1. I'll do 2 clients to actually illustrate to you. Okay, so that's client number 1. And in your coming week number 4 lecture, you'll learn about how to draw a client-supplier relation, right? So let me just tell you right away here. So let me just put supplier over here, and let me put the clients over here, right? So this is the clients, this is the supplier, okay? So now as soon as you have some declaration of the variable over here, so you have client-supplier relation, for example, object of type A. So the way to do it, as you will learn this week, will be there is a client-supplier relation over here. Okay, so usually it's double arrow, but doesn't matter. Okay, so client-supplier, and then you should put a label. And label should be the name of the supplier, right? So that should be objects. And over here, you don't have to say colon A anymore. It's redundant because the direction of the arrows already suggest the supplier should be of type A. So you don't need to say that. Okay. So all you got to say is just say A over here and then just say object here. That's client-supply relation. So now, let's say in the context of this particular client class over here. So now, number 1 and number 2. Okay. So now we have to know very well, will number 1 compile? According to what I have set it up. Will number 1 compile? Anybody? Once you get through these two questions, I think export status is not challenging to you anymore. Okay, good. Jiahao, you said no. I'm pretty sure because how do you check it? Basically, first of all, you know that this particular feature call is made under the context of D. Is D one of the exported clients over here? No, it's not. So this will not compile. Similarly, F2 is made in the context of D. Is D one of the list classes over here? No, right? So that's also not going to compile. So the way to make a compile is really to say you can only call F1 in the context of maybe class C. You can try that as well. Sorry, in the context of class B. So if I have class B over here, for example, I'll just make one more example. Class B, and then you can say objects of type A. And then if I say objects dot F1, so this will be okay, because now I'm making this particular feature call in the context of B, and B is one of the exported clients over here. And similarly, if I say objects of dot F2, and similarly, F2 also lists FB as one of the exported clients, so that will be fine too. Okay, so now you can think about, in some way, it's a very different ways of specifying what the potential clients might be. That's about export status. In Java, it's meant to be an implementation language, so this kind of issue may not be so necessary to be handled at the implementation level. So in IFO, yeah, you can definitely specify to say what clients you want to export the feature into. Okay, I think for now, at least for your lab number 2, you don't have to worry too much about export status. We already specified them for you. It's later, maybe when you do your projects for lab number 3, you got much more freedom about using your own classes. In that case, you can definitely specify more fine-tuned about your export status for the classes. Okay. Okay, but we'll definitely also get to this with a different example later when we talk about week 5. Okay. Okay, so Nora, you said it is good, sure, but this way the supplier needs to know who his clients are. Okay, very good question, very good question. So you're right, in some way, the supplier class, for example, in order for me to know, for example, I need to list B and C here. So that means I know there's gotta be B and C somewhere, right? Sorry, that's not C, just B and C somewhere. You're right, but remember design is more like a continuous process. So maybe in your first draft of this particular feature, you may be only realizing I may only get feature maybe class B, but later on as I develop more and more other classes in my system, I might decide maybe for this class C I should also add it into the feature export status. So it's more like a dynamically it might just be kept being updated. So I would say that's fine, right? Yeah, but you're absolutely right. In order for you to use the export status, you should know who the client should be. Otherwise, you cannot be precise, right? To specify the list. Yeah, that's a catch. All right. Oh, another thing to mention very quickly, okay, because I think somebody talked about the inheritance. Yes. Yeah. So to be more precise over here, we should say exported to B and B's subclasses. So that's the complete definition. So for example, let's say we got class B over here, right? Let me just put it into a box. Okay. And then if I got another class over here, let's say I got class B, let's say class D, let's say. And class D inherits from, let's say, class B, right? And then etc. So now, even though, and now in class D, and let's say we still say object of type A, and then if I say objects dot F1, and also objects dot F2, right? So now, would it be okay? The answer is yes, because I'm calling F1 in the context of B. Sorry, I'm calling F1 in the context of D. Okay, D over here. Even though D is not explicitly mentioned in over here. However, D is a subclass of B, which is listed over here. So that will be considered as okay. Okay. Similarly, object.f2, and you can see that it's not explicitly listed over here, but D is actually a subclass of B. So that's also fine. Okay, so it's actually a very general mechanism. So whenever you list any class over here, you're basically saying either that class directly or its subclasses, right? Okay. All right. Okay, I believe that's what Jiahao was asking about. Yeah. Okay, good. Okay, guys, so that's about basically everything I saw on the chat. It's just about export status. I'm glad you asked that question, but don't worry, it's going to be handled maybe more systematically. I'm just making up some example on the fly. So you will be learning some when we learn about the singleton pattern in week number 5. And in that case, we have to be careful about setting the export status for your client classes. And we'll speak about it because that's a very important design decision to make. And we'll talk about it. Yeah, just stay tuned for the lecture. All right, guys. So that's about the two things we talk about. Okay, export status and also the model feature. Okay. Any other questions, please? You can ask me now on the fly. Okay, I'll try to respond as much as I can. Any questions? Okay. Mahor, the client has to specify the type of variables to use, whereas the supplier can just use the generic variable G. Let me try to read it more carefully. Okay, the client has to specify the type of variable to use. Yes. So what Mahor is trying to say is about using the generic class, right? You're right. So supplier apparently is the supplier for a particular class. So you would say class over here, let's say foo, and then you can have as many generic parameters as you like. So this way you declare the generic parameter. Let's say if I simply say G here, and then whatever, right? So once you declare this particular G, you can use it anywhere in the class. The scope for using the generic parameter G is within this particular class, right? So that one is about the supplier, okay? And when you say a client, right? So that's a supplier. And when we talk about the clients, think about the clients of a class. So every time you have a client-supplier relation is when you declare some variable. And the variable might be either maybe a local variable, or it could be an attributes, or it could be maybe implicitly the return type of some query, right? So these are the 3 cases. You will see that when you study the lecture series number 4, when I talk about design diagrams. But let's just talk about one typical case. Let's say if I simply declare some attributes in the client, let's say class, let's say foo and bar, let's say. So now the client class may or may not be generic. Okay, it's up to you. Well, of course, if you put the bar as also generic, so that means bar being the clients of foo at the same time is also another supplier, right? So every class can be client and supplier simultaneously, right? So that's not a uncommon thing to have. But for now, I want to make it simple. So I'll simply say bar over here. Let's say it's non-generic. And now if I declare a variable over here, if I say, I'll just say objects over here. And then if you only say foo, let's say, if you only say that, I kind of forgot the latest version for Java, you can try. I believe in Java, if you try to use a generic class over here without specifying the generic parameter, I mean, without instantiating the generic parameter, I believe it will still compile. I believe, okay? But I can maybe double check maybe after today's session. But if you can check it right away, you can let me know. That's as far as I can recall. However, in IFO, their design decision for the language is every time if you're referring to some generic class, you must instantiate every generic parameter. You cannot leave out anything unspecified. So that's why over here, you want to say what G should be, right? So now, given what we said yesterday as well, so now you got options over here, right? Either, let me tell you option number 1. Option number 1, I'm going to put in blue. Either you can say you simply instantiate G into to be something that's existing, for example, string. This will be okay, right? That's option number 1. Option number 2. Remember I said the client class can also be generic, right? In that case, there's another possibility. Let me use orange. So now in this case, maybe it looks a bit too similar. Okay, that's fine. So bar over here, let's say I have H over here. So now I can also choose to say object number 2 over here, and then for foo over here. I'm going to say for foo, I'm going to instantiate the G over here by whatever H will be instantiated. Okay, I'll show you in just a moment. So I can put H over here. So this is also considered as acceptable. All right. Let me just put it into box, and then I'll just give you one more example here. I think for this particular one over here, this one here, you know what? Let me just make the color a little bit less colorful. Otherwise, you may just get confused. Let's say this one's here is simply purely blue, and that's orange. For the blue part, it's actually very easy, right? For the blue part over here is simply just string. So that means the G over here is simply instantiated by string. That's easy. That's what you learned from the lecture. Okay. What I want to talk about is the orange case. What about the orange case? You can see apparently the orange case, we're saying that whatever G that's going to be instantiated is going to be H. However, H itself also has to be instantiated by the clients of the clients. Okay, let me just go one more level, right? But it's actually very common at the runtime, in the design time. So let me just do one more class over here. Let's say clients 2, okay? And then over here, I can say class, I don't know. Let's say ha, let's say ha over here is not going to be generic, okay? And then over here, we're just going to do maybe some decoration. Over here, we can say objects over here, and then it's going to be bar. And over here, we're just going to, I'm just running out of space. Let me say maybe character, which is an existing class. Okay, so now that would be the whole picture over here. So let me now put this into a box. Okay, so now what's happening here, really? So what's happening here is, when we declare this particular variable here, we are instantiating the generic parameter in bar over here, which is H. We're instantiating that by character. So which means this is going to be character. Character, I'll put C here, just char is character. At the same time, we're also going to replace this particular H also by character, which at the same time is also going to instantiate this G over here by character. Right? So you can see the instantiation doesn't have to be just one level. It could be multi-level. That's actually much more common than just a single level. Right? So that's something you want to get used to. So yeah, so Mahmoud, is that okay? What about the contracts? You have to be specific as well there. You mean for the generic parameter? For the contracts, it's a little bit, it's different angle over here. So when you specify contract, it's just about how you call the queries over here, right? So I'll just give you one example. Let's say over here, there basically you're asking about, let's say, okay, let me just use the stack class that you have on your week number 3. Class stack G over here. And then, of course, we got imp, which is an array of G. Okay. Apparently, this is the declaration, and this is some usage, right? And then let's just use the top query. That's simpler for illustration. Okay. So now, of course, this is just another usage of G. So now let's say for the ensure part over here, right? So now you're going to say, let's say we use strategy number 1, meaning that the top of the stack should be the end of the array. So we'll say the result for the top should be the same as implementation that's at the end of the array. So you can say imp.count. Also assuming that the indices start with 1, which is a reasonable assumption. Okay. So now you can see over here, when we specify the contracts over here for the behavior for each routine, it doesn't really quite matter what G is, to be honest with you. Typically, you don't have to worry. They are just simply just an element stored in the collection. As I said before, does the level property of the stack, last in, first out property, really depend on the type of the elements? The answer is no. It doesn't quite depend on that. So they are orthogonal issues, right? So we are saying there are two independent aspects. Okay, they're completely independent. Number one is about generic parameter. They specify the type of items stored in the collection. Okay, and also number two, let me just put a separator over here. Okay, you know what? Even better, I can just make some space for myself over here. Okay. Okay, that's good. And number two is actually important. So number two is what you talk about as the contracts over here. Number two is about the contracts. So this is more like a specification of the behavior. For example, the behavior for the stack, it should be last in, first out. In this case, it usually not dependent on the type of items. So number one and number two, they're completely independent of each other. So over here, you can see what we are doing over here for the behavioral specification is just to see if the result is equal to the last element in the array. What the element really is, what the type it really is, either Boolean or string, or maybe a person or a count, doesn't matter. It's just the last element in the array. Okay, so these two are completely independent. Okay. All right, so hopefully that makes sense to you. Okay. All right, any other questions? No problem, no problem. Guys, do you have any question about lab number two? I'm more than happy to answer your lab number two question if you have got started already. I think I might just want to do something very similar to lab number one. I do really want everybody to get started as early as possible. So I will try to get back to you. I'm just looking over my schedule. So I'll try to hold maybe another similar like a Q&A session this week. It wouldn't make much sense to hold it maybe next week because it's already too close to the actual due dates. I'll try to make it either Thursday or Friday. I will try to make some time, maybe 1 hour to 90 minutes, to maybe go over some important parts I think you should pay attention to about lab number two. Also to clarify some ideas over there. I think that might be useful. I'll be in touch with you just about what time, okay? Not sure yet which time, but tentatively Thursday or Friday. I'll let you know, okay? But if you got any other questions related to anything, please let me know. Otherwise, I should let you go, right? Questions? No questions? Guys, don't be shy. Well, maybe everybody is doing well, with the lectures. I presume they're clear, so that's why you don't have that many questions, in which case I'll be happy, but you gotta let me know. Okay, I'll pause for maybe another 1 minute or so. If you really have no questions, then you can still drop by my office hour today, which will be 4 p.m., right? If you want to speak to me in person, that's also fine. Okay. Yeah, sure. If you want to ask me a private question, no problem. You can, how about drop by my office hour, and then I will talk about it. Okay, I got one question here. Can you explain for the sequence a little bit? Sure. Which part about the sequence? So what aspect of the sequence do you want me to explain? If you can be a little bit more specific. It's fine, Yang, yeah. So you can speak up if you like. Just tell me which part of the sequence you want me to explain more. So there are many things I can explain about a sequence, but which part? Okay.
Maybe, sir. Sir, maybe.
Yeah. Go ahead. Yeah. So which part do you want me to explain? Go ahead. Speak up.
Yeah. So basically, for the square, we are using that only for the model, right?
You mean for the sequence? Yes. You're only using that for the model. Yes.
Okay. So Okay, okay, I see, I see. Maybe I can ask you during the office hour because maybe I need to organize. I have several questions, but
No
I have,
problem. Drop by my office hour then. No problem. Okay. Yeah. I got one question here from Gleb. Okay. Can I go over? Okay, sure. No problem. Yeah. Yeah. Let me talk about it. So it's about constraint genericity. Okay. No problem. I'll talk about this. So in your lab number 2, I think it's a linear DB class you're talking about. Okay. Let me write it down. Linear DB. Okay. I think you got key first, K. So remember the rule for declaring generic parameter. Whatever name you use over here should not be clashing with any existing name. So we talked about this yesterday. You can also refer to the recording. Okay. Let me get to Gleb's question right away. So he was asking about so curly brackets and then comparable. And also we got hashable. Good. Okay, over here. And also we got V over here, right? Okay, good. Okay, let me put another 2 classes into context, and then you will see what I mean over here. Okay. And let me just show you something over here. So first of all, this particular class inherits from. Actually, that's a good question. So I can explain something which I haven't done so far. If I say that one inherits from, let's say database, right? So for those of you who got a chance to look at the starter code for lab number 2, you would know what I'm talking about. If you haven't, that's okay. Maybe that'll be a good motivation for you to start, maybe right after this meeting, okay? So database over here, okay? So now we will actually say K and also V. Okay, I'll talk about everything together. Just give me one moment. And then we have feature over here. It's a section, okay? And then I'll just leave out the export status for simplicity. So we got keys, and also we got also the values. One of them is called values. That one there is a hash table. And for the hash table, don't forget, you have to put a value first, followed by the key. Okay, so now we're going to say V, and then we're going to say key over here, all right? And then let me just move this away. So just V and K. Okay, I'm almost done. Just let me put one more class in the context. Actually, I got to put database and also hash table. Okay, there's one class over here. Let me make it a little bit smaller. Might be nice for me to show you a little bit of architecture. Oh, sorry. Okay, let me resize this one here. Okay, let me put it here. Okay, let me put it here. Okay, let me put 2 more classes in the context, and then we'll talk. So the first class will be the database, which is a superclass. Database. And then over here, if you look up the definition of a database, I believe that one there is saying key should be comparable. And then also V. We explained about the attach any yesterday. Attach any has to do with the concurrency for the IFA language, which you don't have to worry about for this course. So just pretend that V is just with no constraint. Any class can instantiate V. Okay, so that's about the second class over here. And then, of course, you got other things, okay, etc., right? Okay, let me also put this class in the box. Let me just get one more class, and then we can start discussing. Okay, that's this class over here. And then finally, I want to put a hash table class in the context. It's a library class. Class, and we got hash table. And if you look at the definition for hash table, it has the V, the value, and also the k. And the k should be hashable. Well, if you recall what you learned in 2030, so when we talk about the hashing function for for the hash table, so basically, if you actually want to use your current class as almost like a hash table, you should really redefine the hash function, right? You can think about hashable, which means the class can be defined, can be used to define some hash function. So hashable. Okay, hashable over here. Okay, and the rest. Okay, so now we're almost complete. Let me now just get this class a little bit just even smaller. Okay, so I can put everything maybe just a little bit smaller here. Okay, good. And let me put it here. Okay, so we got 3 classes for us to consider. All right, so now let's think about the architecture, right? So a very important learning outcome for week number 4 is for you to draw the design diagram, and we'll test you on that when you submit your lab number 2. Because for your lab number 2, you have to draw some design diagram, okay? So now you can see that over here, since we are using this particular hash table is a variable declaration, so we must draw a client supplier arrow like this, right? You have seen me done that for for many times already, right? It's a client supplier arrow over here, okay, like this one. And then you should always put a label. In this case, it's a hash table, right? Sorry, it's the name of the supplier. It's actually over here. It's simply just values. So I will put the values over here. Okay, like that. Okay, and then we got basically also this particular class called database. And this is not the client supplier because you say you inherit from database. So there's an inheritance relation. In this case, that's how you draw it, right? You also single line arrow over here. Typically it's red. So when you use the tool that we require to use to draw the diagram, you will see these 2 kind of arrows over there, okay? So this for inheritance, like that, okay? So it's a very simple architecture over here. So now let's see how to understand about these 2 things over here, right? Number 1, what this is saying is, I want to talk about how you use it, and then I'll tell you why it is the case. So in the linear DB, so if I got any other clients, if I declare, let's say, DB, if I say DB is linear DB, and then I need to instantiate K and also V, right? For the V part, it can be anything. So let me just say person, right? Assuming that we have a person, okay? But over here, what should we specify? We should specify a class that is both comparable and also hashable, okay? So where is such a class, right? I can tell you that a typical class that will satisfy these 2 constraints is number 1, let's say integer. When you say a class is comparable, that simply means you have the less than relation defined, right? You also learned about comparable in 2030. So when you say a class is comparable, that means you can compare, either integer or string. And also when you say a class is hashable, that means the value for the current object can be used to define some hash function. So I would say integer and string. So these are the typical pre-existing classes they can use as that's both comparable and also hashable, right? So what would be illegal? Okay, let's say this. Let's say I only have 1 class over here. Let's say my class. Okay, let's say, let me just change the color for this so you can see the distinction. Let's say it's blue. Let's say for the class over here, doesn't inherit from anything, just my class, right? Just typical normal class. So now, let's say this is my class. If I simply put my class over here, would it be considered as a valid instantiation? Okay, so this is actually not going to, oh, I just saw one question here. Am I going to share these notes? Yes, of course. I have been sharing all the notes since forever. So every time when you go to the lectures page, you will see, okay. So sorry for a little bit of distraction over here, but I think it's important. Let me just mention that, right? I'm just worried that you guys might be worried about I don't share notes, so you might be taking notes without paying attention to what I'm saying. Every time if you see the Q&A or the lectures, you can always click on the notes tag. So all the notes are here, so you don't have to worry about it, okay? So just in case you're panicking. All right. Okay, so let me just continue with this. Let's say currently, if I simply put my class over here, it will not compile, okay? So when I say red cross, that means it's not gonna compile because currently my class is neither comparable nor hashable, right? So because any class you want to put it here must be a descendant class or subclass of both comparable and also hashable, but it's not the case now. How can I make it so that it will compile? What you got to do, as I briefly mentioned yesterday, you have to say, for example, inherits comparable, and also you want to inherit from also hashable. These two classes. As soon as you say that this particular class is going to inherit from comparable, you're forced to define that is less. I think it is less than routine. You have to define this particular, pretty much like in Java, right? If you want to define a class to be comparable, you have to define that it's less than method. For hashable, I forgot the exact routine name, but I think it may be something called hash. What does it really mean for you to return a hash code? Something like this. I can look up the details later if I remember, but you can also look it up to see in the hashable class in IFO, what's the feature that you have to implement. That might be useful for you later for your projects. Okay, so far it's just about how you can use it, right? So whenever you want to use a linear DB, you have to pass for the key some class that's both comparable and also both hashable. And integer and string are simply just two examples over here. If you want to make your own customized class, make sure that it inherits from comparable and hashable, right? That's a rule. Okay, so now let me go a little bit further because the reason I drew this particular architectural diagram is to show you why we come up with this constraint over here, okay? I want you to draw your attention to this. Number one, you can see we say that inherits database over here, right? You can see when we pass the K over here, right? You want to see the following. So the K over here, again, is a declaration. And the K over here is a usage, right? That's what we learned from the lecture. Now, if you think about if I want to instantiate a database, the first generic parameter by K, is there any constraint on what K should be? Indeed, K should be comparable, right? So now, in this case, you want to say the K over here must be comparable. It must be, okay? So now, one experiment you can do, because the starter code that we give to you for lab number 2 already compiles, a very simple experiment you can do. If you simply take this out, and then you're going to see that your code will start compiling. And then if you look at the error message there, it's going to say something like to say, you inherit from database where the K must be comparable. However, the K you're using to instantiate it is not comparable anymore because I took it out, right? That's one experiment you can do. Okay, that's one thing, all right? Okay, hopefully so far you're still following me, right? Hopefully I'm going very slow. And then another one you want to look at would be this guy here, hashable. So why do we also need that to be hashable? It's simply because there is a client-supplier relation here. We're using the hash table. And now look at this. So now when we say, again, K over here is where you declare the generic parameter. And the K over here is how you use it, right? It's a usage. Usage number 2. And we are using K in the context of instantiating the second parameter for hash table. And if you look at the hash table over here, the second generic parameter should be hashable, right? So that's why the usage is the K over here must be hashable. The orange constraint over here. So let me just make it more explicit for you. You can see the hash table and the K over here must be hashable, right? And then in the previous case, it should be comparable. So this is why you will eventually see this particular constraint over here. Since the linear DB is going to inherit from somewhere, where K is comparable. And also LinearDB is using something that's actually of hashable key. So that's why you have to take a union of these constraints together. So that's why you have to have comparable and also hashable over here, right? All right. Yeah, Galeb, it's a very long question, a long answer to your question, but I hope that's thorough enough for you. All right. So hopefully that will help you for lab 2. But guys, I think for lab number 2, we didn't really ask you to really fill in the generic parameter. That's what we did in last fall in 2019. But we thought maybe this time we'll give you the challenging exercise for week number 4. So you can do it, and then you can learn from that as well. How about for lab number 2, you don't really have to worry too much about filling in the generic parameter, I don't think. Okay. Good. All right. Okay, guys, any more questions? Yeah, as I said, I'm gonna make everything available to you, so you can definitely use that for your study. Not a problem. Okay. Okay, guys, any more questions? Yeah, my advice to you would be, as usual, I know that you got many other courses to also worry about. Fair. But for lab number 2, you may just want to get started at least by reading the instructions, trying some easy features there, and then you can get to the more difficult stuff, hopefully in the second week. But at least for the first week, get all the easy stuff, out of the way as soon as you can. And don't forget, you also have to draw a design diagram for lab number 2. And to really know about the syntax for design diagram, you need to study the lecture, week number 4. But you can definitely ask me questions for next week. I already saw some questions happening already for week number 4. So I can see maybe the coming series is more challenging than week number 3. That's what I expect it to be. But just put your question there, and then I can imagine next week Q&A might be busier. So we'll see.
Right. Oh, by the way, Mr. Jackie.
Yeah, go ahead.
Yeah, for the design diagram, how should we submit it after we finish it?
Okay, so very brief response to you. You need to use a tool. Okay, let me show you that. Actually, it's good. Yeah. Of course, you will also find the precise instruction in the in the PDF. I'll show you quickly since you asked. There's a website for the tool. It's cloud-based. I believe it's provided by maybe it's a branch by Google anyway. So it's draw.io. Okay, it's a tool over here, and then it's a cloud-based. So just make sure any diagram you put over there, you're gonna save to your device, right? So let me just give you one example here. If you say you want to create a diagram, blank diagram over here, for example, and now just create it. And the extension for the source of the file source is draw.io. Okay, so that's the source you must submit it as well. You want to submit 2 things. You want to submit the source for the diagram. Also, you want to export your source into a PDF. You want to submit both. But you got detailed instruction in the PDF. So I just want to do a quick demo to you. So you're going to say save, okay? And then I already got a library over here in my computer. In your case, if you look at the starter projects, so there's a folder there called docs, standing for documentation. If you go to docs folder, there is something called EECS3311 Bong library, something like that. So you have to import the library to your cloud web browser over here. You got to do it once. And then once you do it, you got all the shape. For example, you can do maybe a class over here. You can do also another class over here, but in the compact view, and etc. And also you got client supplier arrow over here, and also you got inheritance arrow over here. You're just gonna play around, with the shape. And also you got mathematical symbol over here, which you will need. Sorry, it's a little bit small, but it's just a mathematical symbol that you can actually use to present a contract view for your class. And then eventually, what should you submit? So every time before you're gonna save your diagram for sure. You can see the extension over here is draw.io, and then you'll say save file. Let me say I save to maybe just my desktop, for example. I save it. Okay, so that's one thing you got to submit. Number 2, you want to export your diagram. You will say export as PDF. So that's the file the TA is going to mark on. But remember, you have to submit a source as well. If the TA doesn't see the source, they wouldn't modify your, they wouldn't mark your PDF. So you're going to submit both. So you're going to say crop, so you can get rid of the redundant space, and then say export, and then let me save that to my desktop, right? Let me say desktop over here, and like that, okay? So now let me just open that to, okay. Yeah, it's a very ugly diagram, but you see my idea, right? So that's something you're gonna submit at the end of lab 2 by the due dates. So the source and also the PDF. You're gonna include both files in the docs folder and submit together with your project, and the TA is gonna locate them and then mark them, all right? Does that answer your question, I hope?
Yeah, sir. Thanks a lot.
No problem, all right. Guys, any more questions? Let's see this. How much weight does a design diagram carry in the lab? I think the best way, the single choice principle, right? I tend to put information in a single place only, right? So I'll bring you there, okay? Why don't we go to the course syllabus over here, right? If you go to the course syllabus, right, nothing's been changed, okay? So you simply go to, let's say, grading scheme, right? You will see that now we're in lab number 2. Software part, 3%. Design diagram, 2%. So 2% for your diagram. Yes, exactly, yeah. All right. Yeah, guys, any more questions? Yeah, if you feel yourself maybe a little bit behind because you haven't started lab 2 number yet, I think please do it as soon as you can. About the library, you know what? Okay. Give me one moment. Let me just show you an example here. Let me bring up the... yeah, don't worry. Everything you were asking, you definitely can find the answer in the instruction. But since you're asking me, I can mention that briefly to you. Just give me one moment. Okay, good. Okay. So now, when you actually download your starter project from the e-class, right? So the zip file you will download will be something called database.zip, right? If you go into it, okay, so there is a docs folder over here. So that's the XML library file I was talking about. So you have to refer to the PDF instruction to see how you can import the library, okay, number 1. And number 2, so once you have drawn your design diagram and ready for submission, you have to include both the draw.io source and also the PDF export version. So there'll be eventually 3 files over here in the docs folder and submit it together with your projects, okay? All right. Okay. Okay, any more questions for me? Okay. All right. So guys, best of luck to your quiz number 3. Okay, you should really attempt it before Friday, and then yeah, so draw.io library. Yeah, good. All right. So I think yeah, I think that'll be it for today. So if you want to ask me some more question in person, you're more than welcome to. In about half an hour, I'll be available in my office. All right. All right. I'll see you later. Take care.